Hi everyone, this is part 2 of the inequalities video. If you want to see part 1, you can tap on the pop-up screen at the end of this video. So let's start with this question. Here we're given x squared is less than or equal to 16 and we are asked to solve for x. Try to do this question, pause the video, do it. If you are stuck somewhere, you can just press continue again and see how I'm going to solve it. So let me do it now. So we have x squared. What we need to do is take 16 to the left so that we have x squared minus 16 is less than or equal to 0. And this expression here resembles ax squared plus bx plus c. And a is equal to 1 because there is a coefficient of 1 there even if it's not written. This means that a is greater than 0, of course, because 1 is greater than 0. And that means if we were to draw a graph, it would look something like this, right? Because this is a quadratic expression. It's a parabola, basically. So step 1 involves performing factorization. So we can have x minus 4 and x plus 4 is less than or equal to 0. If you don't know how to do factorization, of which I assume you do, you can wait until one of my videos about factorization is available. When it's available, it's going to also appear at the end of this video in the pop-up screen. Okay, so let's continue. So now that you've done step 1, step 2 involves drawing a diagram. Remember, this diagram is very important because you get marks for drawing it as well. And many people don't draw it. I don't know why, but many people don't. So let's draw the diagram. The reason it's concave up, it's because a is greater than 0, as I had said initially. And by the way, remember, the top part of this diagram is the positive side. It's the side where the graph or the expression will be greater than 0. And the bottom part, this one, is the part of the graph where the top where the expression will be less than 0. This expression here. Okay, so now we want to choose the region in which this graph is less than 0. We want a region where x squared minus 16 is less than or equal to 0. Because we have this inequality here, we have to put a solid dot here and here. And secondly, we have to ask ourselves, where is this graph less than or equal to 0? This graph is less than 0 where it's below the x-axis. This is the x-axis. So below the x-axis here, this graph is less than 0. And now, because we know that this graph is less than 0 in this region, we want to know the specific part of the graph that is in this region. The specific part of the graph that is in this region is this one. It's this part here. This part here is the one that's situated in the region that's below the x-axis. Now that we know it, we also need to know the roots, these values here. So to do that, we simply take x minus 4. So we're going to have x minus 4 is equal to 0, x is equal to 4. And negative 4 comes to this side, becomes positive, so we're going to have positive 4 there. And then we have x plus 4 is equal to 0, therefore x is going to be equal to negative 4. So you're going to have negative 4 there. By the way, never put negative 4 here and put positive 4 there. We don't want to see something, you don't want to do something like this, where you have, let's say, positive 3 here and negative 3 there. It doesn't work that way. Remember, in the number line, we have 0 here, we have positive 1, positive 2, negative 1, negative 2, negative 3, positive 3. So if you have, let's say, -3 and +3, it simply means that you have a dot here and a dot there. The negatives are on the left and the positives are on the right. Just wanted to clear that one out. That's why here we have -4 on the left and +4 on the right. Okay, let's continue. By the way, this is step 2. Step 3 is the act of writing the solution. So when you're writing the solution, you are going to include all the values of the graph that are in this region that you chose because of the fact that x squared minus 16 is less than or equal to 0. So you're going to choose this region here in green. So when you're writing your answer, it should be like this. Note that I'm saying x is greater than -4 because because the graph is below the x-axis where if you were to take a dot, if we were to take a couple of dots here, they would correspond with certain x values there. Let's say, for example, you were to take a dot here, that would maybe correspond with -3. If you were to take a dot there, it would correspond with -2, 0, it would correspond with 1, 2, 3, and eventually 4. So it's all those values that are between -4 and 4 that actually make this region true for x squared minus 16 is less than 0. So it's all so you'd have something like this. It is exactly as it's written there. You have -4 on this side and you have +4 there. So you have to take all these values that are in between. Hence, x is between -4 and 4. Make sure that you don't mess up with your inequalities here, because x has to be greater than -4 in the sense that it takes all the values that are greater than 4 locally, and x has to be less than or equal to +4 because it takes all values that are less than 4 but greater than -4. That's why we write it this way. Let's go to the next example. This question is a bit tricky. You can pause the video and watch it. Pause the video and try to do it. If you can't do it, just continue playing the video and see how I solve it. Okay, so here we first need to multiply out here. So -x times x is going to be -x squared. -x minus times by -6 is going to be +6x. So this is what we're going to have. But then we need to have everything on one side. So I'm going to drop the expression as it is. I'm going to take 9 to this side. So it becomes negative, and we're going to have this. So basically we have -x squared plus 6x minus 9. That the whole thing here, this whole expression is less than 0. Okay. So now we know that we need to have this standard expression, and clearly we already have it, and a is -1. So a is equal to -1, which implies that a is less than 0, and when a is less than 0, we're going to have something that's concave down. So if it's concave down, it's still going to be the same as other questions. It's just that the shape is different. So step 1 will involve factorizing the whole thingy. So basically, -x squared is made by -x times x. -9 is made by 3 times by 3. But then we're not sure which of these two numbers has to take a negative. Let me just choose this one. Okay, so -x times 3 is going to be -3x. X times -3 is going to be -3x. When I add them together, they have to give me +6. So one of them has to be positive. Let's see. So if, for example, I put a negative here, this is going to be positive. And if I put a positive here, x times 3 is going to be a positive 2. So 3x plus 3x is going to be 6x. This is the middle term. That's 6x there. So I'm going to end up having x plus 3 and x minus 3. If you want to learn more about factorization, as I've said in the first place, you have to watch the video about factorization where I explain this method in detail. This is step 1. Now let's go to step 2. Step 2 involves drawing, and of course a is less than 0, so we're going to have something that looks like this. And before we do anything, we have to also note the fact that this is the positive side. On top it's the positive side, and on the bottom we always have the negative side, just like on a Cartesian plane. Remember, this is positive, this is the negative side, this is the positive side, this is the negative side. So so if we look at this graph here, we want we want a region where this graph is less than or equal to 0. So where this graph is less than or equal to 0, it's on the negatives. It's here. Less than, here the graph is less than 0, and here the graph is greater than 0. Hence the signs: greater than 0, positive; less than 0, negative. So we want this the part of the graph that lies here. Now, a part of this graph that lies at the bottom where it's negative is this one and this one. We are not interested on this part because it lies on the positive side, and the question clearly states that it wants the x values where the whole graph is less than or equal to 0. But and of course we have to account for this equality sign here. Because of that, we have to put these solid circles here, right, to show that we include these values as well. Okay, now that we've done that, we also need to find the exact values for these roots here. For us to find the values for these roots here, we're going to take the negative x plus 3. So we're going to have negative x plus 3 equated to 0. As a result, you're going to have x is equal to positive 3. Because when 3 goes to the side, it becomes negatives. And the negatives will cancel each other out when you're going to have x is equal to 3. And we're going to also take x minus 3 is equal to 0. X 3 comes to this side and becomes positive. Well, seems like we're only gonna have one root here. So apparently, even though the shape is okay, but because we're gonna have one root here, the graph will look something like this. If there's only one root, then the graph has to look something like this. Because x is equal to 3 and x is equal to 3. So it's going to look something like this. Of course, this remains positive. It's always positive on top. It's always negative on the bottom. Now we want the x values where the graph is less than 0. In other words, we want the x values of the bottom. We want the x values of the bottom. Nothing has changed. It's just that we only have one root here. So it's going to be all the values of the graph. Because if you look at the graph, if you go this side to infinity, the x values are also going to be increasing. And that's still true. The graph is below and it satisfies the question. And if you look at this side as well, the graph, the x values will be going to negative infinity, which also satisfies the graph. So the answer will be x. Let me write it with the black color. Answer will be x is greater than negative infinity and x is less than positive infinity. In other words, it's going to be x is an element of all real numbers such that x is greater than negative infinity and less than positive infinity. Whichever way you want to use. Thank you.